Very glad to have some special guests who have many years experience in the LED industry as our lecturers. Today, we have invited Daryl Barnard from Freeman. Daryl has a lot of experience with Novastar controllers, especially MCTRL4K controller for long-distance data transmission solutions. We are so delighted to invite him to share his valuable experience with us. Same as usual, please leave your question in chat window if you have some confusions. Daryl will answer the question after lecturing him. So now let's welcome Daryl to give us some of his insights.
Thanks, Carl. I appreciate you guys at Novastar hosting these over the last few weeks. I got to tell you, in a time when our industry is really taken a hit, it's been great to have Novastar support to be able to learn and to grow what we're doing on a daily basis. And I hope you all know that this is not something they take lightly. They've done a really good job of putting out information. You can check out the YouTube channel and see all the different things they've put together over the last few weeks and share that with folks who may not able to attend it live because they're doing other things. Tell you a little bit about myself. I'm Daryl Barnard. I'm the LED product manager for Freeman Event Technology. Freeman has been in LED in and out for a long time. In 2013, we partnered with Novastar for the first time and brought in their controllers with some LED products that we picked up from Absent. And we've had a strong partnership ever since. Carl and I talk almost on a weekly basis and go through products and go through things that working that we're trying and doing and get a good partnership together. So again, I appreciate that their working relationship with us. One of the things that we've all struggled with since 4K came into our industry is how do we properly get that to the wall? And so we're going to talk a little bit today about two products from Novastar that we've had great success with at Freeman that allows us to get that 4K all the way pristine signal from the source through our signal processing all the way out to the wall. So let's kind of step through what some of the struggles are. First of all, to do a successful LED product, it's always important to plan and plan and plan. So a couple of things you need to plan for is your port capacity and what cable path you're taking between your processor and the LED panels. That sounds pretty basic and pretty simple, but I'm going to tell you, I've seen a lot of places where they don't do that before they get to show site or to their install, and that's where their issues come into play. Now with port capacity, it's really easy to plan using Smart LCT. And I believe Novastar is working on another session with a deep dive into Smart LCT. But one of the things I want to show you is that you can quickly double check your ideas of how you're going to wire it using it, because what Smart gives you that no other software gives you is that capacity, that indicator down in the bottom corner. You see that little red one, the fifth column in that wall is too big. And so now we get an indicator that we're 128% of our port capacity, which, you know, is going to cause you some issues. And it may work for a moment and then it may fail. So that's going to depend on how you're sending it out. So being able to check this before you walk in the door and know is huge. Now, you know, this port capacity for all Novastar products is 650,000 pixels. So how do you figure out what your port capacity for your individual tile is? That's really pretty simple. You take your horizontal pixel resolution, your vertical pixel resolution, say it's 128 by 128, you multiply those together, and then you divide 650,000 by that, and that will tell you the number of tiles per port. Now, 650,000 is the maximum port capacity. I am a pretty conservative person, so I limit mine to about 600,000, and it's been a little more consistent for me. And the other important thing to remember is square or rectangular configurations. If you're doing long lines, the minute you go down to a next row, it's taking that whole row into consideration. So that's the reason Smart is so great for allowing you to look at it and plan it in advance, and it'll even allow you to export it. So that's a great ability to do that. The next thing is your cable path limitation. How are you going to get your signal from your processor to the wall? Now, with 4K, the reason that became such a big deal with us is we really had a problem finding 4K signal cable over 25 feet that was reliable. We've done some fiber, we've done some other stuff, but every time there have been little issues. If I can keep that 4K processor near whatever my signal is, typically for us, it's a high-res switch like an E2 or a Spider. If I can keep that close, then my signal has fewer issues. But that means often that my processor is farther away from the wall than I want it to be. So let's go over that. The limitations of Cat5, is 100 meters or about 328 feet. Again, I'm a cautious guy because, my income's based on all this. So I cap myself at about 300 feet. If the wall's over 300 feet, is often in the rental world because we're trying to keep it near the high-res switch. For those of you in the installation world, you're going to notice that, hey, I've got a secure closet that I'm coming out of. Then I got to get out to a wall that may be on the exterior or another part of the building. So having the ability to get that signal over that 300 feet becomes really important. And that's what these fiber solutions do for us. Okay, so let's look at the Novastar 4K fiber distribution system. It's made up of the MCTRL4K and for us, the CVT4K. So this gives you a strong backbone between the two of them. We'll go into detail on each of these products, but it is a partnership. You can't do it with one without the other. You can do a 4K wall with just the MCTRL, but you're going to be staying under that 300-foot limitation. If you need to get farther, then that's where the receiver of the CVT4K-S comes into play. Okay? So let's take a deep dive into the MCTRL4K and all of its capabilities and functions. It's a product that's been out for a few years. We got it initially when we were starting to get into our sub 3 mil products. With sub 3 mil, you get into that 4K space pretty much anytime you get over a 5 tall or 10 wide. So we were starting to build 4K walls pretty fast when we got into 2.6 LED products. And so we picked up the first of the MCTRL4K back then. We've stacked them, we've broken them apart, we've done all kinds of different configurations with them, and it's really been a wonderful product. All right, so its loading capacity up to 496 by 2160. It has a maximum width or height up to 7680. So you can do some custom resolution stuff with it to better fit what you're doing. If you can stay with broadcast standards, I found that I'm in a much more stable situation, but the Novastar, the MCTRL4K can do all kinds of unique configurations if your wall is different. Again, when you're taking a 1:1 aspect ratio product, rarely are we doing 16:9 aspect ratio walls. We're often doing stuff that's very close to it, or we're doing unique archways. We're doing all kinds of interesting configurations, ceilings, ramp ceilings. The 4K can handle it all. Okay, but remember, it does not have a scaler in it. It is a processor. So anything I'm sending into it, I'm sending it as the resolution that I want the processor to take and maybe even output all the way to the wall. All right, so let's take a look at the inputs and go a little deeper into those. It has one DisplayPort input, and it's a 1.2. It has one HDMI input, which is 2.0. And each of those have a maximum of 8.8 million pixels. One thing to keep in mind if you're used to using other Novastar products is there are not loop throughs on the MCTRL4K. So if you're doing a primary and redundant, you will need to 4K DA your signal upstream of the processors. Now you see that there are two DVI inputs. Those two DVI inputs actually can be broken apart and used as two separate inputs. Now their combined resolution is only 8.3 million pixels, so it's a little lower than either the HDMI 2.0 or the DisplayPort 1.2, but you can still get a full 4K out of it. It has a mosaic and a multi-card mode, and they can do dual link resolutions up to either 3840 by 1080 or 1920 by 2160 at 60. So basically what you're saying with this is you can take two of them, use those two DVI inputs, and make one 4K. So either stacked on top of each other or side by side. That's a real nice feature. The other thing as we go in through it is you can actually break it, and 1 through 8 can be one wall, or 9 through 16 can be the other wall. And I'll explain that a little more in a moment. Okay, so the DVI mode, as we talked about, is the mosaic mode. We talked about you can either do top and bottom, or left and right. So you get both of those. The multi-card mode and the mosaic mode. Each DVI works as a standalone processor. So you can make it where one wall is coming off of DVI1 input and one wall is coming off DVI2 input. But just keep in mind that each of those inputs are tied to certain output ports. So DVI1 is tied through 1 through 8. DVI2 is dedicated to 9 through 16. Okay? Hope that makes a little bit sense. When you look on the front of the panel, you'll see that it can auto cycle through those inputs, or you can select those inputs. If you select them, it'll stay solid there. If you put it on auto, it will find the strong signal and lock onto that. And it goes in the order of DisplayPort, HDMI, DVI1, then DVI2. Once it locks onto that signal, it shows you there what it's seeing coming in. And you have some other basic features on the front panel, including you can see the port connectivity. All right, the biggest difference with the MCTRL4K is the outputs. With the 660, we had 4 output ports that were RJ45. With the MCTRL-R5, which is a 4K by 1K processor, we upped that to 8. And if you've had the 660 Pro, then you've had the 6 EtherCon connections. And the MCTRL4K takes that all the way up to 16. So each one of those 16 is 650,000 pixels in 8-bit mode. Now, your numbers reduced approximately half in 10 or 12-bit. But the great thing about them is, like the R5, is those are EtherCon connectors. So you can use really good EtherCon snakes. You have strong reliability. There's no tabs falling off and cables falling out. So it's real strong, stable connection. I really like the way this product works. Also, what we're talking about today, you'll notice the optical outs, which is the fiber connections. Now, if you don't have SFP ports or SFP modules in it, they look like this, which is straight out of the manual. If you have SFPs stuck in them, you'll probably just see the LC connectors on there. There's 4 fiber outputs. One is primary for ports 1 through 8, also called master. 2 is primary for ports 9 through 16, again, master. And you see they're color-coded there, blue and green, to match up to those ports. 3 is redundant for ports 1 through 8, and 4 is redundant for ports 9 through 16. Now, if you've been around Novastar long, you're familiar with redundancy. But this redundancy is different. This is redundancy in communication between the processor and the data distribution unit, which is, for us, is going to be the CVT4K-S. So there's no programming with this redundancy. When you plug the cables in, that's how they pull up the additional data, okay? So let's talk a little bit about the SFP modules. SFP modules have been around networking for a long time. If you've done any kind of networking and network switch, you've worked with them before. I will tell you, you can get them from a lot of places. I have a couple just examples here. I strongly recommend the Novastar because they've been tested and tried in the units. You can play a little bit of configuration work with them as you get other products. You can put stuff in it. I can't say the reliability if you buy just something off the internet. If you get it from Novastar, I know it's going to be solid. So there's both. For SFP modules, you can get either single mode or you can get multi-mode fiber. What's the big difference? The big difference is that wavelength of the wavelength of the signal, and then what that gives you is the transmission distance. So let's take a look at that. The single mode will come with an LC optical connector on it. The wavelength will be about 1310 nanometers, and the transmission is up to 10 kilometers. If you're here in the United States, that's about 6 miles, okay? So that's really a huge amount of transmission distance that I can get if my wall's in an install situation and I need to have control in another building someplace nearby, okay? Multi-mode gets a little shorter wavelength. You're at 850 nanometers, and that changes your transmission distance down to 300 meters, or about 900 feet. Again, it's really going to depend on your SFP modules, and the SFP modules have to match. If I have single mode in my transmission system, my MCTRL4K, then I have to have single mode matching, same manufacturer, same everything, in the receiver, in our case, the CVT4K-S. Okay? Most SFP modules are coming with the FC connectors. If you're like me in the rental world, most of our rental stuff is all ST connectors on it. So that's really fixed easily by a small jumper cable that then can have a barrel on it. Now, we use a lot of TAC12, because one thing you've got to keep in mind with these is when you look at the connectors, you'll see there's a send and a receive in the fiber. And so it's actually taking 2 fibers per port. So if you're using your 4 fibers, 4 ports, you're actually using 8 fibers. So these TAC8s, TAC12s, TAC24s become a lot more important in those cases, okay? Really all we're doing when we go from LC to ST is a cable connection, is a connector end change. So it's not having to change through any kind of hardware device except for that little cable, jumper cable. At Freeman, we put, Will Farman, who's one of our designers here, we'll put connector plates on the back of every one of our racks so that we have the LC coming out with a small jumper cable going to a patch through cable of ST connectors. So it makes using rental fiber real easy. All right, so let's take a look at the status on the front panel of we talked a little bit about the inputs and about looking at the ports, but you can also look at the fibers right here. And it shows you, in this case, down in the bottom corner, you see 1, 2, 3, 4. In the example from the manual, 1 and 3 are connected. And so you've got throughput on those. 2 and 4 are off. So the status on is for 1 and 2, if it's always on, the port's connecting and it's working perfectly. If it's off, it's not connected or it's not working. That's pretty basic and pretty simple. Port 3 and 4 is a little different. Again, if it's always on, it's connected, but it's not set up. It's not working properly as the redundant port. And 3 and 4, if it's always on with a small check mark next to it, then it's set up properly and it's got it's working with the redundancy taking effect. Okay, again, everything you can see on the front of this display is really helpful for diagnosing some of your issues. The other things you'll want to notice in that heads-up display is the USB or the network control. Again, in this manual version, this picture from the manual, it does not have USB or network control set up. So it's just operating as a standalone processor. Okay? So we've kind of been through that. Now let's talk about the receiving side of this, because we can only do so much transmitting. We also have to be able to somehow receive this signal. So this is the fiber converter CVT4K-S. I love this box because it's strictly a distribution network. It is just going to take the signals that we're sending out of the 4K and send it to the wall. You cannot connect, if you look at the back of this, you cannot connect a source directly to it. The source has to come through this MCTRL4K. It cannot come straight into the CVT4K-S. Okay? So let's take a little deep dive into it and how it operates and what it does for you. It's got 16 Nutrix Ethernet ports on it, just like the 4K processor. It has 4K optical fiber interfaces. Again, 2 master, 2 slaves. Each one takes 2 fibers, so you're using up 4 of those to get all 16 ports. Again, the ports are tied to the colors. So 1 is the first 8 port, 2 are the second 8 ports, 9 through 16, and then 3 is redundant of 1 and 4 is redundant of 2. One of the neat things about this box is it has 2 different ways it can be powered. It has a typical UPC power connector on it. It also has a PowerCon connector on it. So when you place this data distribution box up on your truss, you can now plug a power con in it off of your breakout and go straight into the box. It's so low power, you can actually loop out of your LED panels into it and it will power the box. So that gets over the need of having to have a 110 circuit just to power this receiving box. It's got great, the panel on the front of it is really limited, but you don't need much information. It's showing you the opticals are connected and it's showing you that the tiles are connected. There's no advanced configuration you have to do with it, okay? So here's how that kind of things connect up, and I'm sorry for my crude drawing, but I think it kind of gets the point across. You're tying port optical 1 into optical 1 on the fiber receiver, 2 and 3 and 4. And again, each one has a send and a receive fiber to them. You connect that up, and you have all 8 fibers going between the 2 boxes. At this point, you're able to output to the box. Okay. So we talked about the color code matches of the optical ports. Blue goes through 1 through 8, green going through 916. It has to be used with a processor sender. You can use, there's several products that do processing sending now. Of course, the 4K we're talking about, the UHD Junior, even the 660 Pro can be worked as a sender card. It's a receiver and it's limited to whatever the processor's doing. So if you have it hooked up to something like an R5, which only has 8 ports, you're not going to be using ports 9 through 16. You're going to be staying on those first 8 ports. Okay, so even though it has the connections, it won't have the capabilities if the processor doesn't have the capabilities. So the control connections, there's 2 control connectors on there. One is by Ethernet and one is by USB. The Ethernet connection is, again, network connection over TCP/IP network. I'll be honest, I haven't done that because you don't have to communicate with the box in a standard configuration. The only time you're using these control connections is if you're needing to upgrade the firmware or doing something directly to the box. It's a pretty basic box, so you don't have to work with it often. We use the USB, and you'll notice that's a USB-B connector. We'll use that when we're upgrading our firmware, but unless we're doing that, we don't worry about connectivity to it because the connectivity is the receiving side of the signal. Everything else, it's just passing through. Okay, we talked about the power connectors. The standard UCP power cable, you'll notice that there's a switch, the power switch between the 2 of them. That's your off-on switch, and which direction you toggle it depends on which of your power systems you're using. So if you want to use the power con, you're going to put the switch in the up mode for on. If you're using the UPC, then you're going to put it in the down position, and then the middle toggle position is actually turned off. All right, so this is kind of a standard configuration. It's not a large wall because I just needed to get the point to you of how it's all configured out. So this is a 7x5 LED panel configuration. We've got the 4 fibers between this MCTRL4K and the CVT4K-S. We have the 6 data lines between the CVT4K-S and the LED panels. There's 3 primary and 3 redundant. The MCTRL4K processor is backed by our video source. Our CVT4K-S unit is at the wall, and we can be, with single mode fiber, we can be up to 6 miles away, but using all 8 of those fibers in that TAC-8. Okay, pretty basic configuration. There is nothing I have to do to the CVT4K to get it to come on. Once I power it up, it has those indicator lights, it knows its role in the world. I do not have to program in Nova any differently than if I was just programming directly in the box. So when I launch my Nova and I program out my wall, I'm doing it just like I'm attached to the MCTRL4K. I'm doing it all at the 4K. The 2 boxes are working in conjunction and they're talking together to figure out how to split this signal up to our wall. Okay? It said no configurations necessary. It's plug in and ready to go, and there's no special setup. The ports duplicate on boards of the sending processor. I was in a situation where I lost signal through my fiber because we had a bad fiber. I was able to take a port directly out of my 4K processor and send it to that portion of the wall because that part of the wall was closer to me. One of the things I want you to understand is the MCTRL4K and the CVT4K-S are sending the same signal out simultaneously. So at that point, you have 16 times 2, so you have 32 ports sending out signals. Now, they're going to be cloned, so it doesn't mean I gain that many more pixels, but I can, if I'm building multiple walls, have one wall work off the 4K processor there and one wall work off of the CVT4K-S. I probably wouldn't do that in a standard configuration because I want my feedback and I want to know what's going on. But in an emergency situation, it's kind of good to have. And if you're only using 8 ports for one wall, you could use 8 ports for another wall, and everything will work just great. So let's look at the front panel in the CVT4K-S. You've got indicator lights that are pretty basic. You've got indicator lights for your optical ports, which are listed as master and backup. So the master on the upper one is ports 1 through 8. The backup for the blue on the right is ports 1 through 8, and then the greens on the bottom. All it indicates to me is that I have connectivity between the CVT4K and the processor. Then we have our indicator lights for our 16 outputs, and it's just like we have on our processor, so that when we see connectivity to the LED tiles, it kicks on. If there's no connectivity, we have a bad port or a bad receiving card, and we lose our connectivity, we can tell it on the front panel. One thing I will say about this box is I often mount it up above the wall in a truss structure, someplace that I can get to it if I need to, but that is out of the way, but gives us a central place to put our cables to. Because all it is acting as that distribution network to go back down to the tiles. Troubleshooting, pretty basic. If you don't have any lights on it, you're going to confirm your power source. Make sure that switch is in the proper position for the power source you're using. Are you using the power con or are you using the UPC? The lights on the optical connectors, no lights on the ports. Confirm that your Cat5s are connected properly. Lights are on the ports, but not on the optical connectors. That means we have some fiber issues. One common thing to check is to see that your send and receive haven't gotten swapped. If you get those back in the right order, then they'll process the signal properly. If you have a glitchy or unstable signal, the most likely culprit, if it's doing the whole wall, is a firmware version difference between the sending card and the receiving card. In our discussion today, it's really about the MCTRL4K and the CVT4K. We want to make sure those firmwares match. Now, you see on the slide here, the CVT4K right now is currently 1030, and the MCTRL4K is currently 1240. So the numbers aren't matching, but they're both the latest numbers, okay? If you have any kind of lack of communication, that's most likely the culprit. So let's talk a little bit about how we take that and make sure we are on the same page with our firmware. Okay, again, we're connecting with the, we're connecting through the USB A to B. If you log in to your Novastar Nova LCT software, then you do your asynchronous login like you've always done. Then with the point with all 7 of your icons across the screen, you're going to type ADMIN, and that's when your firmware submenu pops up. It's not something that's published into looking up on a certain menu. You do it with all 7 of your icons across the screen. Type ADMIN, and this will pop up. That's really designed to keep the novice user from accidentally punching into it, but it can be a little confusing sometimes when you're looking for that, okay, how do I get into my firmware? Just type in ADMIN. Now you notice in the bottom right-hand corner the word refresh. As soon as you launch up, it won't list anything until you hit that refresh. And when you hit that refresh, it's going to go out and it's going to pool the network. And when it pulls the network and it sees everything, that's when it's going to list what it has. And you see here our CVT is showing up as a sending card because it doesn't necessarily know how to classify it. You then hit browse to send it to the path where you've downloaded the new version, and then you hit the update. At the end of the update, click refresh again and make sure you can confirm the update. As always, when you're doing any kind of firmware, make sure you've got stable power and that nothing can lose that connection during the transfer, because the last thing you want to do is brick your device. All right, so what we've been through the whole system, it sounds on paper like it's really complex, but when you put it into practice, it's really pretty basic. One is just replicating the ports of the processor. So it's been very stable for us. We've used it in arena venues. We've used it in large convention centers to get signals all over the place. Fiber is so much more reliable than our Cat5, Cat6 configurations when we get to that 300-foot mark. Well, do you have any questions? I'm kind of new at this Zoom thing, so I'm not sure how I'm supposed to be looking up all my chats. Oh, there we are. And what about latency? Good question, Pure SVG. Latency, we don't have the latency with the fiber. You're not going to have an issue of it adding milliseconds back to it. It is the same as the processor inside of it. From everything I've read and seen, Carl, let me know if you guys have heard difference. I've never seen low latency with this. I've not used the low latency feature in the 4K because it is the 3 milliseconds the whole process adds has not been a problem for us. What you gain when you go to low latency in the Novistar 4K system is you drop 2 of those milliseconds off, but your hands are, it's more restricted on how you can wire and configure the situation. You wire straight down, you don't do any kind of loops ups. So we haven't been using the low latency mode. Okay, any other questions? The silence is stunning.
I think you shared a lot of details. I think the details answers every question they're going to ask.
Well, again, I think it's a great product with a lot of ability to get you guys where you can get your processors out and you can keep that signal stable. 4K is beautiful when it's running right. And what this product allows us to do is to get that signal to those LED tiles well. So thank you, Novistar, for the good product.
Okay, thank you, Daryl. Thank you for sharing with us, and I also learned a lot. So we're gonna publish this video on our YouTube channel, so you can just review the video if you lost some information. So thank you everyone for joining with us. And for the next webinar with our guest, I think we're gonna post on the Facebook as well as the newsletter. Just keep an eye on this. Thank you. Have a nice day, Daryl.
Thank you, brother. Have a great one.
Thank you. Bye.
Bye.